Welcome back. As you know, the main topic in this chapter is calculating with letters, and so far we've learned to multiply, add, and subtract. And in the following lessons we will extend this to include calculations with powers. So what is a power? A power is a short way of writing a repeated multiplication. For instance, 2 times 2 times 2 can also be written as 2 to the power of 3. The number 2 is the base, that's the number that we multiply by itself, and this 3 tells us how often the number 2 occurs in our multiplication. So this 3 is called the exponent, and it's written as a small index to the top right of the base. So we read this as 2 to the power of 3, or 2 to the third power, and it means the same as 2 times 2 times 2, which is 8. If we increase the exponent, we will multiply by 2 more often. So 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. And 2 to the power of 5 means we multiply by 2 another time. And 2 to the power of 6 means we multiply by 2 another time. Whenever our exponent grows 1 larger, the result doubles. And the reason is that the base here is 2. The base can be a different number. 3 to the power of 3 means 3 times 3 times 3 is 27. And 3 to the power of 4 means 3 times 3 times 3 times 3 is 81, and so on. If the exponent increases by 1, the result of our calculation now triples. A square is just a special name for one of the powers. So as you know, squaring a number means multiplying it by itself. So 3 squared is 3 times 3 is 9. And we can also say 3 to the power of 2 is 9. 3 itself is the same as 3 to the power of 1. It is a product, but it has only one factor. We usually omit the exponent here, but we will see that it can be useful to realize this, that when a number or letter doesn't have an exponent written next to it, it actually still has an exponent of 1. In the order of operations, powers come before multiplication and division. So basically what you already know about squares applies to powers. So for example, in 3 times 2 to the power of 3, we also say 2 cubed. We first evaluate the power. 2 to the power of 3 means 2 times 2 times 2, which is 8. So we write down that this equals 3 times 8, which is 24. Here we look inside of the brackets first. So we evaluate 7 minus 2 squared first. The power goes before the subtraction, so we calculate 2 squared, which is 4. And now we need to calculate 7 minus 4 and then cube the result. 7 minus 4 is 3, and because this is a positive integer, we don't need these brackets anymore, so we can just calculate it like this. 3 times 3 times 3 is 27. We will need to take care to keep the result between brackets in other cases, because it matters whether our base is positive or negative. So a power can have a negative base, and if the base is negative, that is, if our power tells us to multiply a negative number by itself, then we have to write that negative number between parentheses, between brackets. And the exponent now tells us to raise the value of whatever is between the brackets to a certain power. So here we square the number negative 2. That means multiplying it by itself. Negative 2 times negative 2 is positive 4. If we raise negative 2 to the power of 3, we get negative 2 times negative 2 times negative 2. And we already saw this is 4, so this is 4 times negative 2 is negative 8. So if we increase the exponent by 1, we multiply by negative 2 again, and we get positive 16. Negative 2 to the power of 5 is 16 times negative 2 is negative 32, and negative 2 to the power of 6 is negative 32 times negative 2, and a negative times a negative is a positive again. So you see the results alternate between positive and negative numbers. The second example, however, is different. The exponent here attaches only to the positive number, because the negative sign is basically a multiplication by negative 1, and powers go before multiplication. So if we have minus 2 squared without any brackets, what that means is we take 2 squared, which is 4, and then we multiply by minus 1, so we get negative 4. And in the same way, minus 2 cubed is minus 2 times 2 times 2 is minus 8. Minus 2 to the power of 4 is minus 2 times 2 times 2 times 2 is negative 16. and so on. And make sure you understand this difference completely, because it would be just too bad if the difference in notation messes up your results later. And again, the basic idea behind it is the order of operations. These exponents are greedy, and they want to raise the first thing they see to a certain power. So if we want to include the negative sign in that process, we have to use brackets to force the exponent to look at the entire expression. Now let's end with a few examples. It's always good to pause and find the solution by yourself first, and then check it. So the first one, this is the number -2 raised to the power of 4. So -2 times -2 is already 4. 4 times -2 is -8. And -8 times -2 is 16. In the second example, we have the number 2 raised to the power of 4. And after that, multiplied by -1. So 2 to the power of 4 is 2 times 2 times 2 times 2 is 16. So negative this will be -16. Here we have the number -3 raised to the power of 3. So -3 times -3 times -3. -3 times -3 is 9. And 9 times -3 is -27. Here we have the number -1 raised to the power of 5. That's the first thing we have to evaluate. So -1 times -1 times -1 times -1 times -1. How do we calculate that? Well, it's just the number 1 multiplied by itself a bunch of times. 1 times 1 times 1 times 1 times 1 is just 1. And then we have to keep track of what happens to this negative sign. A negative times a negative is a positive. Times a negative makes a negative again. Times a negative makes a positive. And then times a negative makes a negative in the end. So because this is an odd number, the result of this power will be negative. So the result of the power is -1. So we get -1, and the two minus signs cancel each other out, or a -1 becomes +1. Here we have to evaluate inside of the brackets first. 5 times -2 is -10, and we are raising this whole expression to the power of 4. So the result will still be between brackets. So we get the number -10 raised to the power of 4. So that's -10 times -10 times -10 times -10. That's a negative times a negative times a negative times a negative. So the result will be positive. And 10 times 10 times 10 times 10 is 10,000. Final example, here we have two powers. This one and this one. We can evaluate them simultaneously. The first one is 3 to the power of 4. So 3 times 3 times 3 times 3, which is 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So this becomes 81, but then, of course, the negative sign in front of it makes it -81. And this is -3 raised to the power of 4. A negative times a negative times a negative times a negative is a positive. And again, 3 to the power of 4 is 81. So this becomes -81 plus +81. And of course, the result of that is 0. So these were some examples of calculations involving powers. In the next video, we will look at how powers fit into what we already know about simplifying formulas.